We get the original values in the red color. That's the amount of noise that we have in the given data set. Now when you look at the linear model predictions, it is almost fairly a flat line, which is not very promising. Whereas when you look at the XGBoost model, it is giving us better predictions and it looks promising. It looks as something that we can rely on. First, let's show you the comparison of the classic linear regression model versus the XGBoost model on a housing price dataset. So first we will need NumPy, then I will need pandas and matplotlib as well. And then from scikit-learn.model selection, I will import the train test split to split the data into training and test set. So model selection, train test split. And then we will import the classic linear regression model from sklearn.linear model. We want to import linear regression like that. And then from the main XGBoost library, we will import the XGB regressor. Now let's just run this. That is done. Now let's create the dataset itself. For our dataset, I'm not going to import it from anywhere else such as Kaggle or scikit-learn datasets. I'm just going to create it myself because we're just testing how XGB regressor is better than linear regression. So to do this, let me just create a data variable and then actually have this copied in the form of a dictionary. These are some random generated values using the NumPy module. I will quickly run over this. By the way, this is a housing price prediction dataset. Just for simplicity, I'm just having it like this. First parameter will be size, and then I have that to be between 1,200 square feet and 3,500 square feet. Of course, we're generating 500 values. Well, this is done with randint from the NumPy module. And similarly, I've generated the number of bedrooms, bathrooms, and then the distance from the city. Followed that up with the year built, the year when the house or the structure was actually built. And I also have a garage capacity parameter and also a classification column, which just signifies if that building has a swimming pool or not. And then we will also have the neighborhood category, if it's present in the urban area or the suburban area or in the rural area. We use the random choice function to generate one of these three values and then set that to the given record. Again, size will be 500. And then price. This is our prediction label. I have it to be between 100 and 500. Let's just remove this comma and this will be our data. So what I will do now is convert this to be a data frame so that we can pre-process this using pandas. So pd.dataframe, pass in the data like that, and then print this. And there we go, we get 500 values of the housing price prediction dataset that we just created. Now what I will do is do a bit of pre-processing. As we see over here, we have created three classes for this column, neighborhood category. Now I'm going to perform a one-hot encoding to segregate them into three different columns and have them to be 0 or 1 based upon their values. What I will do is use the pandas function. So the updated df will be pd.get dummies, and inside the df we will mention the columns to be, again I will explain this once I type this out fully, neighborhood category, drop first equal to true. So what this does is it will look for this column over here and then identify the number of classes present in this, and then it creates that many columns. For example, we have three classes over here, so three columns will be created, and then it will be marked as 0 and 1 according to their values. When you actually now look at the data set, we see for this neighborhood category in suburban, it's given as 0 and 1. When you look at the 499th record, it says that it's 1. That means that this structure, this building, belongs to the suburban area. And then similarly, we have that for urban, and then I don't see rural. I guess we don't need this. Let's just run this. And yeah, there we go. We see rural, suburban, and urban. They have been marked as 1 or 0 based upon their values. So if it's suburban, that means that structure is built on the suburban area, and then similarly for urban and rural as well. Now let's just segregate the entire data set into X and Y. So X value and then prediction label will be, actually, let's just do it separately, df.drop. We don't need the price column alone for X. Have that in the column, so access equal to 1. And then that of Y will be just the thing that we just deleted. So df.price, like that. So this will contain all of the columns except the price column, which will be our Y label. Now before performing the train test split, let me just have a look at the X value. Yeah, we have all of the columns except the price column, which is actually what we want. And then when you look at the Y, which is our prediction label, it has only the price of that specific house in thousands. Now what I will do is the train test split, we imported that function from scikit-learn model selection. What I will do here is create xtrain, xtest, and use the function that we imported, train test split, pass in our X and Y, X, Y, and then we have to mention our test size. That is, our test set should contain 20% of the values. I'm just going to type in test size will be 0.2, like that. And now our data set is almost ready. Let me just do that in a specific code cell. Xtrain When you run this, actually I forgot to run this. Now there we go, we get only 400 rows because 100 other rows are put in the test set. Let's just test that out. And okay, we have 100 rows over here. Now that we have done that, let's just create the model straight up. First, we will start with the linear regression model. This is the base model for performing regression tasks like predicting the price of a house based upon given features. Now, if you don't know what that means, I will link a video related to that. But anyways, let's just call this to be our linear model and then use the class that we imported above, regression, and then we type in the linear model.fit function, pass in our x-train data and then our y-train data, x-train, y-train. This is the data that we provide to the model for training. Now, linear regression has a set of rules and it uses those rules to identify pattern on the provided data by using the fit function over here. Now, similarly, I will create the XGBoost regressor as well. So let's just call this XGB regressor. Actually, let's just call this XGB model, XGB regressor. Again, we imported this class above. Similarly, use the fit function to provide the data, .fit, like that. Pass in the x-train data, the y-train data, and then create two new variables, linear predictions, done by the linear regression model will be linear model.predict, pass in the x-test data, and then for XGB predictions as well, let me just call this XGB predictions, will be XGB model.predict, pass in the x-test, like that. Now let's just run this. We're not obviously going to see anything over here. Once we visualize it, we can evaluate how the model is performing. So first, to visualize, I'm going to use matplotlib. We use the figure size to set a bigger figure. Figure will be fig size 12,6, like that. And then now start plotting. We will first have the original values, that is the y values. So y test dot values. Then I will set the color to be red. And then the label for this will be actual. This is the original price for a given index. And then I'm going to set the marker to be O, like that. And then now we will plot down the predictions of the linear model. So linear predictions, color will be green, linear predictions. Again, marker will be O, like that. Just going to copy paste this for the XGB prediction, XGB, like that, and change the color to blue. Set the PLT title to be linear regression, XGBoost. Set the X label and the Y label, sample index. And then Y label will be the corresponding price of the sample index. I'm just going to call this to be price. Type in PLT legend and then PLT.show. Now when we run this, we should get a plot of 3 different lines. So run this and there we go. We get 3 different line plots. So right as we see here, we get the actual line. And when we look at the linear model predictions, actually I forgot to change this to be XGB, like that. Run this once again. By the way, if you've been getting value out of this video, then consider subscribing. Now we get the original values in the red color, and this fluctuates between 150 to around 500. That's the amount of noise that we have in the given data set. Now when you look at the linear model predictions, it is almost fairly a flat line which fluctuates around 270 and 320, which is not actually very promising. Whereas when you look at the XGBoost model, it is giving us better predictions and it looks promising. It looks as something that we can rely on. Now this is why XGBoost is preferred over linear regression. It uses the decision tree system and hence it identifies outliers better, it identifies the patterns better, it does the math well. So linear regression can be used for simpler tasks, but then it's always recommended to use gradient boosting such as the XGBoost model to perform any kind of complex task like this. Now as you see, the XGBoost can also be used for logistic regression as well, which is for classification, and over there as well, XGBoost outperforms logistic regression, the model used for classification. We will be making a video on that, and if it's released, we will link it at the end.